I'm going to starting chapter 2, that is steady state sinusoidal analysis. With respect to chapter 2, this is the lecture 1. Chapter 2 and this is lecture 1. First you have to see some introduction. Then after that we go for what are the different terminology in steady state sinusoidal analysis. What are the different terms we have to use. Then what is the phasor representation, how to find average and RMS values. All this you have to concentrate. This is some introduction. We know that AC is nothing but a alternating current. All of you have known this. Alternating current. Then DC stands for the direct current. Stands for direct current. Yes, friends. Why AC supply is more popular? We know that we are generating the AC, we are transmitting the AC, distribution is also in the form of AC, and utilization is also in the form of AC. Most of the power is in the form of alternating. In some applications only we are using the DC. Most of the applications we are using AC quantities. Why this AC is more popular? Electric energy is generated and used as AC because it is having more advantages than DC. It offers more advantages than DC. Then what are the advantages? One of the advantages of AC, alternating current can be step up or step down, but this is not possible in case of DC. We know that by using the transformers, AC we can step up or we can step down, but we don't have DC transformers. Mainly transformers means we are taking the AC transformers. We can step up and step down the voltage. Then you have the doubt here, sir, what is the need of step up the voltage and what is the need of step down the voltage? Electrical engineers, mainly you know this. Even some point of view, even easy students also you know this. You take the example, power is generated at 11 kV. But even though power is generated at 11 kV at a generating station, we are not transmitting at 11 kV. Let this is the generator. The power is generating at 11 kV. Then at generating station, there is a step up transfer. At the generating station, there is a one step up transfer. We can step up the voltage. What is the need of step up the voltage? This 11 kV step up to, you have to step up to 400 kV. Let 400 kV transmission line, then we are step up to 400 kV. The reason why you are step up the voltage, to reduce the power loss. If you transmit the power at high voltages, if the power is transmitted at high voltages, the power losses are reduced. Because of that reason only, we can step up the voltage. You have to transmit the power at high voltages. When the power is transmitted at high voltages, the power losses are less. Once it is step up, but we don't utilize this 400 kV. We have to utilize for industrial application 33 kV or 11 kV. We have to utilize for domestic applications 230 volts or 440 volts. Whatever the 400 kV is transmitted, again you have to step down this voltage for utilization level. Why you are step up the voltage? You have to transmit the power at high voltages, then power losses are reduced. That is, if power is transmitted at high voltages, if power is transmitted at high voltages, then power loss is reduced. Power loss is reduced. That's the reason why you are step up the voltage. Why you are step down the voltage? In order to bring the voltage level to utilization level. Utilization levels in some industries 11 kV they are using directly, 33 kV they are using directly. In domestic applications, you have to bring into 230 volts or 440 volts. For this purpose, you have to step down the voltage. That is possible in only with alternating quantities, not with direct quantities, DC quantities. Okay, this is one. This is the most important reason for generating and using electrical energy as AC. This is the one of the reason, most important reason why AC is preferred. AC can be generated at high voltages. AC can be generated at high voltages, but DC cannot be generated at high voltages. Why DC cannot be generated at high voltages? Because sparking starts at the commutator at high voltage, due to which commutator gets damaged. Students, even EC students and even electrical students also, minimum knowledge on the electrical machines. You take the DC generator. In DC generator, there is a commutator. If you try to generate at high voltages using DC generators, then there is a sparkings at the commutator, then commutator will be damaged. That's why we can't generate at high voltages. High voltage AC generators are much popular, much simpler and cheaper than DC generators. These high voltage AC generators are much simpler and cheaper than DC generators of the same range. It is because in AC generator there is no commutator, which is costly part and is damaged. If you take the AC generator, there is no any part of the commutator. What is the purpose of using commutator in the DC generator? What is the purpose of using commutator in the DC generator? In DC generators, to convert AC to DC. In DC generators, AC to DC. In DC motor, DC to AC. That you see in your mission subject. But high voltage AC generators are much simpler and cheaper than DC generator. This is also one more reason why AC is preferred. AC induction motors are simplest in construction, cheaper in cost, and requires less maintenance, whereas DC motors are complex. In load side, we are preferring mostly induction motors. Induction motors are driven by AC. Then we want AC only. That's the reason why we are preferring the AC. In the olden days, we are using DC motors, but nowadays, in most of the applications, induction motors are preferable as compared to DC motors. If you have to drive the induction motor, what type of supply is required? AC supply or DC supply? AC is required. That's why AC is more popular. These are the different reasons, or these are the advantages why you are preferring the AC as compared to DC systems. But in AC, which waveform is more popular? We are preferring the sinusoidal wave. There is so many AC waveforms are there, but sinusoidal is more. AC sinusoidal is more preferable. In AC, sinusoidal is preferable. In AC, sinusoidal wave is preferable. Why only sinusoidal? Why not remaining waveforms? In AC, sinusoidal is preferable. We know that in AC supply means what type of supply that? It is a sinusoidal supply. Other than sinusoidal, we can treat it as a non-sinusoidal. It consists of harmonics. But generally, we are preferring AC means, we are utilizing AC means what supply you want? Sinusoidal AC. Why sinusoidal AC is preferred? Nature itself is characteristically a sinusoidal. Nature itself. Take the example. You take the motion of pendulum. In physics you study. The motion of pendulum is just like a sinusoidal. It is a sinusoidal. Motion of pendulum is also sinusoidal. Ripples on ocean surface, like this. The ripples on ocean surface, this one. The ripples on ocean surface is also sinusoidal. Natural response of second order system. To take any second order system, natural response, that is also sinusoidal response. That's the reason why sinusoidal is preferred. We are why AC is sinusoidal is preferred. Why AC is the sinusoidal is considered. Only sinusoidal AC is why you are considering. This is the reasons. Easy to generate and transmit. Easy to generate and transmit. According to Fourier series, any periodic waveform can be represented as a sinusoidal function. This is also one more reason. You take any non-sinusoidal waveform. See, for example, if any square waveform it is given. If square waveform is given. Like this. If you apply Fourier series for this waveform, Fourier series for this waveform, if you apply the Fourier series, then you have to separate harmonics and fundamental. Harmonics and fundamental. Fundamental is also sine wave, even harmonics also sine wave, but multiples of frequency. That means any wave, any periodic waveform you have to take. Any periodic waveform you take, that periodic waveform is represented in terms of sinusoidal functions only. But no doubt at all, it consists of fundamental and harmonics, but it is represented with sinusoidal functions only. This is why sinusoidal is preferred. Why sinusoidal is important. Sinusoidal input is given to any linear time invariant system. The output is also sinusoidal. So analysis of the system is very easy. You studied even in control system also. If you take any linear time invariant system, you take any linear time invariant system. If input is sine wave, if input is sine, the output is also sine. But I am not talking about amplitude and phase, but function. Input is sine, output is also sine. That's why sinusoidal is important. If input is sine, output is also sine, we can easily analyze. We can easily analyze the system. Mathematical handling of sinusoidal is easy because of differentiation and integration of sinusoidal is sinusoidal. Sine shape I'm telling. If you take sine integration, we can get cos. It may be minus cos, leave it, cos. Then cos integration, again you can get sine. Sine differentiation, cos differentiation, sine. You leave it, for negative or positive, whatever may be, you can leave it. I'm not talking about that sine. I'm talking about the function. Sine to cos, cos to sine. Sine or cos, the shape is same. It is a sinusoidal. If you take it as a cos waveform like this, the shape is same. That means mathematical handling of sinusoidal is easy because differentiation and integration of sinusoidal is sinusoidal. But don't think like, sir, a differentiation of sine is cos, sir. Differentiation of cos is minus, sir. Yes, I'm talking about shape, sine shape. Even cos also shape is like that. That's the reason why, as compared to other waveforms, sinusoidal is important wave. We are considering the sinusoidal. That is, our required waveform or our reference waveform is sine only. See, for example, we are using the sinusoidal supply. Our reference is sinusoidal supply. If it is deviating from that waveform means, then we can say that there is some harmonics. Our reference is always which waveform? Sine wave. If this waveform is deviating, means it consists of harmonics. If it is a pure sine wave means, then there is no any harmonics. That's why always our reference is sine wave. Sir, why only we are considering sine wave? Why not other waveforms? Means these are the reasons. Because of these reasons, we are considering sine waves. This once again repeated. In general, sinusoidal signal is preferred because of the following reasons. Easy to handle mathematically. Fourier analysis of any practical periodic signal can be represented by sum of sinusoids. Easy to generate and same points it is repeated. It is dominant form of signal in communication and electric power industries. Generally, you take in communication or even electric power industries, the reference waveform is sine wave. Throughout the world, supplied to homes, factories, laboratories also, sine function only. Nature response is similar to simple pendulum that consider sinusoidal signal. Integration of sine omega t, differentiation of sine omega t, again written as sine omega. This about the why sinusoidal is important. Here I given why AC, why sinusoidal. Why you are preferring AC? In that AC, why sinusoidal is more preferred? Why sinusoidal is we are considering? These are the reasons that you have to consider. Now you have to see some terms related to alternating quantity. These are the terms related with alternating quantity. Terms relating to alternating. Yes. First, I am defining the waveform. What is the waveform? A waveform is a graph in which the instantaneous value of any quantity is plotted against the time. That is, every instant value is plotted against the time. Every instant value is plotted against the time. Then that is nothing but a waveform. You have to plot the every instant value against the time. Then that is called a waveform. Yeah, this is one waveform. This is sine wave. This is also waveform complex wave. It is also waveform triangular wave. It is also waveform square wave. Like that, so many types of waveforms are there. Yeah, this is called, what is the definition of wave? A waveform is a graph in which the instantaneous value of any quantity is plotted against the time. That is called waveform. Next. What is the cycle? How to define the cycle? One complete set of positive and negative values of an alternating quantity is termed as cycle. One complete set of positive and negative values of alternating quantity is termed as cycle. See, for example, in this waveform, positive and negative values, this is called cycle. In this positive and negative values, this is called cycle. In this positive and negative values, this is called cycle. This positive and negative values, this is called cycle. One complete set of positive and negative values of an alternating quantity is called cycle. To take the sine wave, this is drawn with respect to time. This is called one cycle. This is called cycle. See, for example, this is A and this is minus A. Here, the maximum value in positive half cycle or negative half cycle is called amplitude. The maximum value in positive half cycle or negative half cycle. The maximum value in positive half cycle or negative half cycle or negative half cycle is called amplitude. Is called amplitude. Then in this case, what is the amplitude? Here A equal to amplitude. This in positive half cycle, this is called amplitude. In negative half cycle, this is called amplitude. Then where amplitude equal to amplitude, or it is also called peak value. Peak value. Amplitude or peak value equal to A. Or you have negative half cycle minus A, positive half cycle plus A. But peak to peak is defined as, if you take the peak to peak amplitude, peak to peak amplitude, peak to peak amplitude, amplitude is different, peak to peak amplitude is different. It is also called peak to peak value. Then A minus of minus A. This is called peak to peak amplitude, that is 2A. From negative to positive, negative amplitude to positive amplitude, this total is nothing but it's a peak to peak amplitude. One complete set of positive and negative values of an alternating quantity is called cycle. Next, what is the frequency? The number of cycles per second of alternating quantity is known as frequency. If the frequency is denoted by F and is expressed in Hz or cycles per second. The units of frequencies Hz or it is denoted as cycles per second. But point to remember, friends, the frequency is defined for one cycle. It is defined for one cycle. Defined for one cycle. So, for example, this is a sinusoidal. Any waveform can define the frequency. This frequency equal to 50 Hz means this 50 Hz are 50 cycles per second. 50 cycles per second. 50 cycles per second. This is defined for one cycle. This is for one cycle frequency. Always you have to calculate the frequency for one cycle. How to calculate the frequency for one cycle. We don't define frequency for 2 cycle, 3 cycle like this. You have to calculate frequency for cycle, 50 cycles per second. But what are the angular frequencies? We know that you have to write angular frequency equal to angular frequency. This omega equal to 2 pi f. Right? This is in radian per second. Angular frequency is written as radian per second. But frequency is written as cycles per second or H. Then how to define the time period? The time taken by an alternating quantity, to complete one cycle is called time period. It is denoted by T and it is expressed in seconds. That is the time taken by alternating quantity. See, for example, how to take any waveform, any alternating quantity. Here I am taking the sinusoid. If it is like this, let the time taken by an alternating quantity, one cycle, that is nothing but a time. Here, in this case, the time taken by quantity, an alternating quantity to complete one cycle is called time period. It is denoted by T. But there is one more definition is also there. You have to remember like this. It is the time for, it is time at which the starting waveform is repeated. That it is for periodic waveform. I am defining time period for periodic waveform. For periodic waveform, it is time for which starting wave shape is repeated. Starting wave shape is repeated. If starting wave shape is not repeating, then it is a non-periodic waveform. Please repeat. This is called time. Then this is time period. How to relate time period and frequency? Frequency equal to 1 by time period. Frequency equal to 1 by time period. Where T equal to time period. You can also write omega equal to 2 pi f. Then you write 2 pi by T. F I am writing 1 by T. F I am writing 1 by T. Omega equal to 2 pi by T. This is also one more formula. Omega equal to 2 pi f, that equal to 2 pi by T. F I am writing 1 by T. That is about time. See, for example, if the different shape of the waveforms are given, how to calculate time period? See, for example, if it is given like this. what the time period of this waveform? This is 2 seconds. This is 4 seconds. Let t is given in seconds. Then what the time period of this waveform, friends? The time period equal to 4 seconds. The time taken for complete wave. This is 4 seconds. So for example, if they given like this, for different waveforms, how you can define the time period? This is pi, this is 2 pi, and this is 3. You have to take this on omega t axis. Can you tell what is the time period? You have to take what is the time period of this? What is the time period of this waveform? Is not pi. I given one more definition. It is time for which starting wave shape is repeated. The same wave, the starting waveform again started at what time? 2 pi. Then time period equal 2 pi radians. See, for example, if it is given like this, concepts. This is pi, this is 2 pi. Can you tell what the time period of this waveform? Time period of this wave. The starting shape, this is the starting shape. Again starting at what? Pi radius. That's why time period equal to. For example, if it is given like this. This is 2 seconds, this is 4 seconds. Let t is given in seconds. Axis you see. Is it given second or milliseconds? That is important. If any waveform is given, axis also you see. They given in seconds or milliseconds. What the time period of this waveform? This is the starting shape now. The starting shape again starting at 2 seconds. That's why time period equal 2 seconds. The time period equal to 2 seconds. See, for example, if it is given like this. Just by seeing the waveform, how to calculate the time? The time explained. This is 2, this is 4, this is 6. T is in seconds. Can you tell what the time period of this waveform? Come on, students. What the time period of this waveform? T equal to 4 seconds. The starting shape, again where it is started, 4 seconds. Time period equal to 4 seconds. For example, all this fundamental importance, but don't think, sir, you are giving very fundamental. Maybe who don't know about this one, from this onwards, you try to remember. Okay, don't feel like this, even though you know this one. If you don't know some points, that points no, from this you have to note on that. This is pi. What this is 2 pi. Can you tell what the time period of this one? Have taken omega t axis. This is an omega t axis. This is an omega t axis. We can write in t axis or omega t axis. We have to write in t axis or omega t axis. This is pi. This is 2 pi. Then what the time period? You don't take pi here because this shape is different and this shape is different. The shape is not repeating. If the shape is not repeating, total is the time period. 2 pi radians. Total is the 2 pi. Next. If it is given like this, or this waveform, that this is 2, this is 4, this is 6, t is in seconds. Can anybody tell what the time period of this? Is it 2 seconds, is it 4 seconds, or is it 6 seconds? What the time period of this? The starting shape is not repeating. If the starting shape is not repeating, total time, it is not a periodic wave. The time period equal to 6 seconds. Like this you have. That's it. You can write in omega t axis or you can write in t axis. See, for example, omega t equal to if you have to replace t equal to omega t, if you have to replace t by omega t, then you replace t by 2 pi. If you have to replace t equal to, here I written in terms of t axis. No? This I written in terms of t axis. This I written in terms of omega t axis. What the difference here? T equal to omega t. I am replacing t by omega t. Then, yes, 1 equal to omega. Omega equal to 2 pi f. Then 1 by f equal to 2 pi. Then t equal to 2 pi. Replace time period by 2 pi. If you replace t by omega t, you have to write time periods in terms of pi or 2 pi. That is that. Next. One more terminology is phase. How to define the phase? This is important. The phase of an alternating quantity is the time that has elapsed since the quantity has passed through 0 point of reference. Here, this is passing through 0. Then in this case, theta equal to 0 degrees. Sine omega. Phase equal to 0. Now, this is called, this waveform is not started at 0. After 0 only it is started. Then you have to write minus theta. If it is like this, you write minus theta. This is called a lagging waveform. This is called a lagging. Because after 0 it is started, then it is a lagging. Then this is before 0 it is started. Actually, lagging and leading, we can tell by comparing with other waveforms. By comparing. Now I'm comparing, this is the reference. With respect to this waveform, with respect to this waveform is lagging. How much angle it is lagging? Theta. How much angle it is lagging? This is theta. Because reference is the sign. You take this is the reference. Take this is the reference. Take this is the reference. Reference is the sign. With respect to this waveform, this waveform is lagging by angle of theta. This is the reference. Now you take this is the reference wave. This is the reference wave. Take that. This is the reference. If you take this is the reference wave, with respect to this waveform, this is leading by angle of theta. If it is leading, you take plus theta. Leading by angle. In detail, later on that you will see. But how to tell this phase angle? This is leading. This waveform is leading. It is started before this wave. It is started after this wave, but angle of theta. This theta equal to 0 degrees. Here this is lagging and this is leading. This is what exactly phase. Then what is the phase difference? Phase and phase difference, maximum is similar, but how to define phase difference? This term is used to compare the phase of two alternating quantities. You have to use to compare the two alternating quantities. Two alternating quantities are said to be in phase when they reach their maximum and zero values at the same time. For any two waveforms, their maximum value and zero value is occurs at the same instant, takes place at the same instant, then it is a in phase. Then we can say that waveforms are in phase. Their maximum value may be different in magnitude. Values may be different, but same instant takes place maximum and minimum. See, for example, if this is waveform, you take this waveform. Now take this is the one waveform. Their maximum values may be different. Let this is one V1 waveform. Let this is the V2 wave. Let this is V1. Let this is V2. For both the waveform, the maximum values takes place at the same instant, and 0 takes place at the same instant. Then we can say that this V1 and V2 in phase, even the amplitudes are different. Their maximum values and zero values are takes place at the same instant. Then we can say that V1 and V2 is in phase. Then we can say that waveforms are in phase. A leading alternating quantity is one which reaches its maximum or zero value earlier as compared to other quantity. This one. This is the leading waveform. As compared to this quantity, its maximum and zero values are takes place earlier. Here itself I am giving example. You see this one. Here this is one waveform. This you take one more waveform. This. As compared to this waveform, in this waveform, maximum takes place earlier. As compared to this waveform, zero takes place. Zeros are takes place before this waveform, earlier to this waveform. Then it is a leading wave. Then it is a which waveform? Leading wave. A lagging alternating quantity is one which attains its maximum or zero value later than the other quantity. This one. Just by comparing two waveforms, I am telling. By comparing two waveforms. Let this is one waveform. Let this is one waveform. First, I am explaining all these fundamentals. Later in detail. And this. That is a lagging alternating quantity is one which attains its maximum or zero values later than the other one. First it is attained. After this it is maximum. First it is zero. After this it is zero. That's why it is a lagging quantity. Plus sign when used in connection with the phase difference denotes lead, whereas minus sign denotes lag. Here you take this angle is theta, then this is plus theta, lead. If you take this angle is theta, then you have to take minus theta. This angle is lag. Clear, friends? Two angles are lagging or leading. But why you have to take this is plus theta, why you have to take this is minus theta also, I will explain. Later on that you see. Yeah, this is what exactly phase difference. And very important 5-star concept. Based on this, already questions are there in competitive examination. So sinusoidal waveforms, if any waveforms are there, if any two sinusoidal waveforms are there, if you want to compare those waveforms, what conditions must be satisfied? Both be written as a sine waves or both are cosine waves. If you want to compare any two waveforms, both must be sine functions or both must be cosine functions. Don't compare sine and cosine. You have to write both are in sine or both are in cosine. Both be written with positive amplitude. Amplitudes you have to write in terms of positive amplitude. Don't take one is positive, another is negative. Each wave has the same frequency. Both waveforms are both functions are given with the same frequency, then only you have to compare. Otherwise, you don't compare any two sinusoidal signals. Don't compare any two sinusoidal signals. See, for example, I have to explain different examples here. Concept. V1 equal to sine 314t plus 30. So V1 equal to sine 314t plus 30. V2 equal to this is you take V1 equal to 100 sine 314 plus 30. Amplitudes may be different, no problem. 100 sine. V2 equal to 50 sine 314. Now, if you have to compare these two waveforms, this is plus 30. Then how you can write V1 is plus 30. Frequencies are equal. That's why you have to compare. And amplitudes are positive. This is positive amplitude, this is also positive. Now you can easily compare. Then how to write this? V1 leads V2. V1 leads V2. Can you write like this? This is plus 13. V1 leads V2. By angle of how much, friends? V1 leads V2 by angle of 30 degrees. By angle of 30 degrees. Or you can also write same. You can also write V1 leads means what about V2? V2 lags. Shall I write like this? V2 lags V1. V2 lags V1 by angle of 30 degrees. Like this also you can write by angle of 30 degrees. See, for example, if you represent in phasor notation, let this angle is V2 angle is 0. V2 angle is 0. This is V2. V2 angle is 0. Then V1 is leading by angle of 30 degrees. This is V1 angle of 30 degrees. Then leading, you have to take the counterclockwise direction. Leading counterclockwise direction. Lagging, you have to take the clockwise direction. If you are measuring any angle in counterclockwise direction, you take the angle is plus 30 here. Angles leading means counterclockwise. You have to measure lagging is in clockwise direction. Lagging is measured in clockwise. Now, how to say this one? V1 leads V2. We are measuring like this now. V1 leads V2. V1 leads V2. If we measure like this, V2 lags V1. V2 lags V1 by angle of 30 degrees. V1 leads V2 by angle of 30 degrees or V2 lags V1 by angle of 30 degrees. Both statements are correct. Clear, friends? See, I will give some example, then you get clear idea. See, for example, I'm giving like this. Take one more example. V1 equal to 100 cos 100t minus 30. 100t minus 30. V2 equal to 5 cos 100. 5 cos 100. Now it V1 equal to 100 cos 100t minus 30. V2 equal to 5 cos 100. Then how to say this one? V1 lags V2 minus 30 degrees. Na? V1 lags V2 by angle of 30 degrees. By angle of 30 degrees. You can also write like this: V2 leads V1 by angle of 30 degrees. Correct? See, for example, if you want to represent in phasor notation, let this is V2 at angle of 0. There is no angle. Then this is minus 30 degrees. Na? This is V1 at angle of 30 degrees. Now we are measuring in clockwise direction. We are measuring in anti-clockwise, that is counterclockwise direction. Can you measure in counterclockwise direction? Take leading. You are measuring in clockwise direction, take lagging. Yes. Then leading, you have to take angle is positive. Lagging, you have to take the angle is negative. Now, we are measuring this direction. Then V1, this V1 lags V2 by angle of 30 degrees. We are measuring like this now. V2 leads V1. V2 leads V1. V2 leads V1. Or we are measuring like this means V1 lags V2. V1 lags V2. Oh, see for example, to take one more example. V1 equal to 100 sin 100t minus 30. 100t minus 30. V2 equal to 40 sin 100t plus 50. 100t plus 50. V1 equal to 100 sin 100t minus 30. V2 equal to 40 sin 100t plus 50. You have to compare this waveforms. This is one reference. You have to take this is the reference. P at angle of 0. This is the reference. This is 0 axis. Let this is the 0 axis. Then V1 is 100 sin 100t minus. You have to compare these two waveforms because frequencies are equal. In comparing the waveform, frequencies are equal. Minus 30. That is V1 at angle of minus 30. This is V1 at angle of 30. This is V2 plus 50. This is leading. This is V2 at angle of 50. Now tell the students. V1 lagging or leading? V1 is lagging or leading? Come on. V1 is lagging or leading? Lagging. This minus 30, I taken this direction. V1, this we are measuring like this. V1 lagging. V2 by angle of how many degrees? How many degrees, sir? V1 lagging V2 by angle of how many degrees? 80 degrees. 30 plus 15, 80. If you measure like this, V2 leading, V1 by angle of how many degrees? 80 degrees. Both the statements are correct. By angle of 80 degrees. V1 lagging V2 or V2. This is clockwise. This is counterclockwise. That is anti-clockwise direction. Like this, you have to compare. Even two voltage waveforms are given, two current waveforms are given, voltage and current waveforms are given. Same procedure. See, for example, I'm giving like this. One more example. Can you try this? V1 equal to 100 sin 100t minus 30. V2 equal to, so this is 50 sin 100, 50 sin 100t minus 50. Can you try this? Come on, do it. Write in terms of lagging and write in terms of lead. Come on, wait. Yes. If you have to compare this waveform, these two functions, at this reference, I'm taking this. V1 at angle of 30 degrees. It is a lagging, minus 30 lag. V1 at angle of 30 degrees. What about V2? V2 is at angle of 50 degrees. This is 50 degrees. Then what is the angle between V1 and V2? Understood? V1 is at angle of 30 degrees. What about V2? V2 is at angle of 50 degrees. This is 50. Now what about this angle? Angle between V1 and V2? 20 degrees. Angle between V1 and V2 is 20 degrees. Now tell the statement. V1 leads or V2 leads? You can measure like this. Leading. Measure like this. Lagging. V1 leads V2. Both are same side because both are negative. V1 leads V2 by angle of how many degrees? 20 degrees. By angle of how many degrees, friends? 20 degrees. What about V2 lags V1? V1 by angle of 20 degrees. V2 lags V1 by angle of 20 degrees. This is correct. See, for example, if they given like this, V1 equal to 100 sin 100t minus 30, 100 sin 100t minus 30, V2 equal to 50 sin 314t plus 30. Can you compare these two functions? Can you compare these two functions? Come on. Students, just by seeing this one, this frequency is 100, this frequency is 314. Frequencies are unequal. That's why not comparable. Frequencies are different. Frequencies are different. Frequencies are different. Then these are not comparable. These are not comparable. See, for example, if they given like this, one more last one. V1 equal to 50 sin 100t. V2 equal to 100 cos 100. Amplitudes is different, no problem. But frequencies must be equal. Yes, frequencies are equal. Frequencies are equal. That's why here there is no angle, here there is no angle. That's why in phase. That is wrong. I told already. You have to compare both are sine, both are cosine. Then only you have to compare. You convert sine into cos or cos into sine. You have to convert sine into cos or cos into sine. Okay. Shall I write like this? This is 50 cos 100t or 90 minus 100. 90 minus 100. 90 minus 100. Or you can also write 50 cos of 90 minus theta. So 90 minus 100. Cos of 90 minus theta cos theta. You can also write this. You take negative is common. Cos of minus theta cos theta. That's why cos of 100t minus 90. Both are same. Cos 90 minus theta sin theta. But this 90 minus 100t I am writing as 100t minus 90. 100t minus 90. Now this is cos. This is also cos. Now you have to compare. This reference. This V1 is, V2 is this one. In fact, this is reference 0 degrees. V1 is 90 degrees. V1 is 90 degrees. Then what is your answer? If you measure in this direction, lagging. This direction leading. V2 leads V1 or V1 lags V2. Correct? V1 lags V2. V1 lags V2 by angle of V1 lags V2 by angle of. It's correct, sir. V1 lags V2 by angle of 90 degrees. Or V2 leads V1 by angle of 90. Or by taking both are sine also you have to compare. By taking both are sine also you have to compare. Or both are cos also you have to compare. Here I written sine 100t is cos of 90 minus theta sin theta. Again you can get same function. But 90 minus 100t I am writing 100t minus 90. Even though you take negative is sine cos of minus theta cos theta. That's why you can get this. Like this you have to compare. Now you see some important observations with respect to sinusoidal waveform. I already given what the importance of sinusoidal, but some important observations that yes, I will have to write. All these are the fundamental points with respect to AC analysis. Let's consider a sine wave. Even current waveform is given or voltage waveform is given, same points are applicable. I am taking the voltage waveform. Let's consider a sine wave. This is omega t. This is Vm and this is minus V. Let this is V of t. This is pi This is 2. This is a sinusoidal. What is the instantaneous value? How to write instantaneous value? Instantaneous value. V of t equal to Vm sin omega. The instantaneous value equal to V of t equal to Vm sin. This is the instantaneous value. For any sinusoidal function, how to write instantaneous value equal to Vm sin omega. If you take any standard sinusoidal wave, the standard sinusoidal by considering angle also. For standard sinusoidal, V of t can write Vm sin omega t plus or minus pi. Where pi is the phase shift. Take that. Pi is the phase shift. This also is called time shift. Phase shift, or is also called time shift. This is phase shift is in degrees, or you can also take in radians. Okay, degrees or radians, and you have how to convert phase shift degrees into time shift also. Later on that you see. Okay, this is the standard form. But you have to take this is plus minus, then positive for you have to take the leading. This plus pi indicates leading. This minus pi indicates lagging. So that is the standard form. In this case, what is the omega? Omega equal to angular frequency. This is equal to 2 pi. This also equal to 2 pi by t. This point already 2 pi by t. Then you write V of t equal to Vm sin omega is 2 pi by t. That is 2 pi f into t. 2 pi f into t is also equal to Vm sin of 2 pi by t into t. It's a representation of sinusoidal, where f equal to 1 by t. This is frequency. T equal to 1 by f. This is time period. Omega units, f units already given. Let's go to that. Then how to write a peak amplitude or maximum amplitude? Peak amplitude or maximum amplitude. Or simply amplitude. Different ways. Amplitude or simply peak value. Different names. This is equal to V. Peak amplitude or maximum amplitude or peak value equal to this. What is the peak to peak amplitude? Peak to peak amplitude. All these are sinusoidal. Peak to peak amplitude. It's also called peak to peak value. Peak to peak value. How much? Is equal to 2 V. Current is given 2 I. Voltage is given 2 V. Next. What is the RMS value? Very important. The RMS value of sine wave. RMS value equal to Vm by, that is amplitude by root 2 is taken as a RMS. How to calculate this also later I will explain. But this is for sinusoidal function. Vm by root. Next. What is the average value in one cycle? Average value in one cycle. Average value in one cycle is 0, because this positive area equal to negative area. In one cycle, the positive area equal to negative area. If it is asked what is the average value for half cycle? Average value for half cycle. This is equal to 2 Vm by pi. Average value for half cycle, it is a 2 Vm by pi. Then you have to define the form factor. For a sinusoidal wave, the form factor is calculated by RMS by average. RMS value by average value. But during calculation of form factor of sine wave, you don't consider the full cycle. If you consider the full cycle, average value becomes 0. If you substitute 0 here, you can get infinite. That is meaningless. Understand, sir? During calculation of form factor, don't consider the full cycle. You have to take the half cycle. Then RMS value is Vm by root 2. Then RMS value is Vm by root 2. Average value is 2 Vm by pi square. Then pi by 2 root. This is equal to 1.1. Then what is the form factor of sine wave? Form factor of sine wave is 1.1. But if you have the doubt, sir, average value 0, sir, why you substitute? If you substitute 0, you can't define. But you have to define. That's why you take the half cycle. The form factor of sine wave is equal to 1.1. Important. What is the form factor of sine wave? In all the subjects, they are using this value in different calculations. I'll take this one. The form factor of sine wave is 1. Next. Even not only sine wave, even cosine wave it is given. Even cosine wave is also given. These points are applicable. For example, let's consider a cosine waveform. Let's consider cosine wave. How to write like this? This is cosine. This is for one cycle. This is Vm. And this is minus Vm. You have to take this is one cycle. This is for one cycle. This pi by 2, 3 pi by 2. Then you take for one cycle. This is okay. For this case also, what is the amplitude? Amplitude is Vm. What the RMS? RMS equal to Vm by root. What the peak to peak value? Peak to peak equal to 2 Vm. Peak to peak amplitude. Same points are applicable. Only instantaneous value is different. If you take instantaneous value, this is V of t. That is Vm cos omega. This is in terms of cosine. Vm cos omega. Clear. But this Vm cos omega t equal to Vm sin 90 plus theta. Sin 90 plus omega. Sin 90 plus theta is cos theta. Then you have to write this is equal to Vm cos of sin omega t plus 90. Cos is equal to Vm sin omega t plus 90. Sin 90 plus theta, again you can get cos theta. Okay, these points we have to consider. Say for example, if the problem is given like this. Can you try this simple problem? V equal to 100 sin 100 pi t. 100 pi t. Simple fundamental problem. Calculate time period and frequency. Then calculate time period and frequency. Come on, do it. Time period and frequency. In this case, what is the time period and what is the frequency? Then what is omega? This total is omega, 100 pi. Omega equal to 100. Then 2 pi f equal to 100 pi. This is omega, sin omega t form. Then pi cancel. What is f equal to 100 by 2? That is 50 Hz. 50 Hz. Frequency is 50 Hz. This is for one cycle. Frequency is defined for one cycle. Then what is the time period? Time period equal to 1 by frequency. 1 by 50. This is equal to 20 milliseconds. That means, what do you mean by frequency equal to 50 Hz waveform? A 50 Hz sine wave is nothing but if you take the 50 Hz sine wave, this is the 50 Hz sine wave, right? Then what is the time period? Time period equal to 1 by 50. This is equal to 20 milliseconds. That is, this time equal to 20 milliseconds. If time is 20, one cycle is 20. 50 Hz frequency means 50 Hz frequency is one cycle is 20 milliseconds. If one cycle is 20 milliseconds, what each half cycle is 10 milliseconds. That's the meaning. Each half cycle is exists for 10 milliseconds. A 50 Hz sine wave is nothing but a 50 Hz sine wave is nothing but the total one cycle appear for 20 milliseconds. Each half cycle is appear for 10 milliseconds. Each half cycle is appear for 10 milliseconds. So for example, for the following waveform, calculate time period and frequency. For the following waveform, waveform, calculate time period and frequency. Calculate time period and frequency. Can you check it? Time period and frequency. For the following waveform, you have to calculate what the time period and the frequency. This is the given waveform. This is 5 milliseconds. This is given as 5 milliseconds. Then for this case, you have to calculate what the time period and the frequency. Let the amplitude is given 100 hertz. This is omega. Or if you have to take this is t axis, direct milliseconds, 5 milliseconds, t axis. For the following waveform, calculate time period and frequency. Here given is half cycle time period. That is t by 2 equal to 5 milliseconds. T by 2 equal to 5 milliseconds. Then what is t equal to? 10 milliseconds. T by 2, half cycle time period is 5 milliseconds. T equal to 10 milliseconds. Then what is the frequency? 1 by t. That is 1 by 10 milliseconds. This is how much you can get? 100. 1 by t. That is how many? 100 hertz now. This is correct. So this is 100 hertz frequency. One more example I'm giving. For example, if it is given like this. For the following waveform, calculate time period and frequency. For the following waveform, calculate time period and frequency. Time period and frequency. Can you check it? If the waveform is given like this. This is a periodic waveform. And this is V. This is 10 milliseconds. 10 milliseconds. Then what is the time period of and frequency of this waveform? Here given is how many cycles? 2 cycles. Here 2 cycles. But generally time period is calculated for 1 cycle. That is, for this case, given 10 milliseconds is not t. Here given is 2t. This point is t. And this is also t. This for one time period, 1 time. This is 2t. 2t equal to 10 milliseconds. Then what is t equal to? 5 milliseconds. Time period equal to 5 milliseconds. This is the answer. Time period is how much? 5 milliseconds. Given is 2t. Then what is frequency? Frequency don't take 10 milliseconds directly. You have to calculate frequency for 1 cycle. 1 by 5 milliseconds. That is 1000 by 5. This is 200 hertz. This is the see how to calculate the time period and frequency. How to calculate the time period and frequency. And last example before going to the next topic. Yeah, this is the given sine wave. This is 100 volts. And this is minus 100 volts. This is pi. This is 2 pi omega. Now, can you write what is the amplitude, friends? Amplitude equal to how much? 100 volts. Peak amplitude. That is equal to peak value. Can you write what is the peak to peak value? Peak to peak value. How much? 100 minus half minus half. That is 200. What is the RMS value? The RMS value equal to 100 by root. RMS value equal to 100 by root. Yeah, this important parameters that you get. It is about some introduction with respect to sinusoidal steady state analysis. Why AC supply is preferable? Why sinusoidal is preferable? What are the terms related to what are the terms related to AC analysis? Then how to calculate time period and frequency, how to calculate peak value and RMS value of sine waves. The next concept is very important. Already questions are there in competitive exam. What is average value? What is the definition of average value? how to calculate the average value of different waveforms, how to calculate the average value, what is RMS value. It is also called effective value. RMS value is also called effective value. How to calculate the RMS value of different waveforms, RMS value calculations, average and RMS values of different waveforms that I have discussed. This is about the today's session, students. I think next class 8 o'clock you have the signals and systems. Any doubt? Thank you. This is about the today's session. You collect this PPT from Telegram channel. Still who are not joined, please join this small gate. All are small letters. If anybody having the doubts, please raise your doubts. Otherwise, ending the session. Tomorrow concept very important with respect to AC analysis. Don't miss it. Phasor representation is very important. After going for the fundamentals, how to calculate average and RMS values, phasor notation. Then we go for the, if AC supply is given to resistance, inductance, RL circuit, RC circuit, RLC circuit, all these later names. Series RL, series RC, parallel RL, parallel RC, all these later names. This is about the today's session. Thank you very much. I'm ending the session.